So now that we've dealt with the end behavior of a polynomial function, that helps us tell what degree it is, what sign the leading coefficient is. Now we're going to look at the zero behavior. What happens when the graph touches the x-axis? Well, there are three different situations we're going to deal with. And we're going to deal with them through the function that's outlined here, which we could actually write a little bit more compactly as x minus 1 squared times x plus 2. Now, this fact is going to lead us that we have a 0 or an x-intercept at 1, and we have a different x-intercept at negative 2, which, looking at the graph to the left, we have. What changes is how the graph behaves at each of those zeros, or each of those x-intercepts. The x-intercept at negative 2, the graph simply passes straight through on its way through. At 1, the graph actually bounces off the x-axis. That is due to the fact that there is an exponent of 2 on that factor. So that exponent is also called the multiplicity. Essentially, it's how many times that bracket would appear if the function was written out longhand like it was in the text of the question. So when you have a multiplicity of 1, or just the bracket with no exponent, the graph will flow through the x-axis straight away. If you have a multiplicity of 2, then the graph will actually just touch the x-axis and then bounce off of it. Lastly, if you have a multiplicity of 3, the graph will come up to the x-axis, not exactly at the x-intercept. It will then flatten out and then proceed through the x-axis. So it's almost a hybrid of the bouncing off multiplicity 2 and the straight through multiplicity 1. You might call it a hesitation, or whatever helps you to visualize this fact, that this is how multiplicity 3 behaves.